Hello, everyone. Welcome to this webinar. My name is Mackenzie Jackson. I'm a senior developer and security advocate at GitGuardian. And today we're going to be going through some of the results that we've found from our State of Secrets Sprawl report for 2024. So let's get into it. I suppose a good place to start in here is to kind of talk about what am I talking about or referring to when discussing secrets. Well, in this context, I'm talking about digital authentication credentials. And typically, these are things like your API keys, your security certificate, your credential pairs, anything that allows us to access external services or systems or ingest decrypted data. These are really the crown jewels of our organizations. They give access to everything that's important: our databases, our infrastructure, our networks, our applications, our payment systems. Right? All of this runs on secrets. So these are extremely critical. And what often happens with secrets is that if we are able to discover one and make it inside a protected environment or network, then we can typically find more of these secrets and gain additional access into areas. So as a hacker, they're constantly trying to find these. And we can point to lots and lots of different breaches that have used secrets, perhaps as the initial access point, or perhaps as a way to elevate their privileges and move laterally for systems after they've already obtained access to a system or a network. One thing that's really important to know about secrets in this context is that they're made to be used programmatically. That is to say, they're not meant to be used by humans. They're meant to be used by processes and systems and our tools. Now, why that is important is because it means that they're a high value candidate to end up in something like source code, because we code them into different things. How we're meant to handle secrets as software engineers or developers is very specific. They're meant to be stored in local memory, for example, and they're meant to be kind of stored in a vault or a secrets manager and highly protected with lots of access control and fine-grained logs. But often what happens is that they end up being hard-coded into our source code, which then ends up in our version control system. And even if we later remove these secrets, they end up in the history. So we're facing this big dilemma with secrets. On one hand, they're extremely sensitive, the crown jewels of our organization. But on the other hand, they often end up leaking or sprawling into lots of different places. Let's talk about one of the places that these often end up. You're probably familiar with this site. This is GitHub. Now, GitHub is the largest code storage website on the internet, right? Billions and billions of commits are made to GitHub every single year, just in public spaces. And GitHub is kind of interesting. It's a really important part of the software development ecosystem. For one, it stores most of the open source software that runs everything today. It's the central place where that is stored, accessed, and developed. On the other hand, it's also used by developers as a way to interact with the community, show off the portfolio, learn new skills, or contribute to these open source projects. So it's really important. And what this often means is that even if your organization has no relationship to GitHub, it still should be considered as a risk factor in your ecosystem because your developers will be using it. And what we often see is that source code from organizations can accidentally end up public unintentionally on places like GitHub, often through employees' personal accounts. Now, if there are secrets in that source code, they too can end up being public. One of the things that GitGuardian do every year is we monitor continuously all of the public activity that happens on GitHub. So last year, over 1 billion commits were made to github.com just in public code repositories. 1 billion. It's an absolute huge amount of data. And what we do at GitGuardian is every single time one of those commits is made, we scan it and we try and identify if any secrets have leaked within it. And we do this over 1 billion times a year. So when someone makes a commit to GitHub, that ends up being public if it's going to a public repository. It's then published on the GitHub API where we grab it, we scan it for secrets, and obviously there's two options. It has secrets or it doesn't. And if it does have a secret, we have a program called our Good Samaritan, which is where we email the developer responsible to let them know that they leaked a secret. And as a byproduct of that, we're able to understand lots about the types of secrets and how secrets are leaking out there in public spaces like on github.com. And each year we publish something called the State of Secrets Sprawl report. And what this report is it's really looking at all of the secrets that were leaked out over the previous year and how many of those we've discovered, what they are, who leaked them. So if we just look at the high level numbers just at the start, we can look at how many secrets were actually leaked in 2023. So if anyone here wants to have a moment to take a guess at how many secrets they think were leaked in 2023, I'm going to give you a hint. It was a lot. In fact, it was nearly 13 million secrets that were leaked. 12,778,599 to be exact. And that was about a 28% increase of what we experienced of the previous year, the last time we did this report. So this is absolutely monumental. These are such a huge amount of sensitive information. Now, one of the challenges that you may put to me is that how do we know that, in fact, 13 million secrets that we discovered were real secrets and not just something like a high entropy string? Well, that's a valid point. And what we're able to do is we use individual detectors. So we have over 300 individual detectors that are looking for things like AWS keys specifically, or Twilio keys, or Algolia keys specifically. And then once we find those keys, what we're able to do a lot of the time is validate that it is actually a real secret. So if we find an AWS key, for example, we will make a call to AWS to check to see if this is actually, in fact, a real AWS key. So that's one of the areas and one of the reasons why we can really confidently stand by the numbers that we put up there. Now, we've been doing this for several years, and in fact, each year the problem gets worse. In 2020, there was 3 million secrets leaked, 6 million, 10 million, and now 12.8 million. So we can see that we're not really getting better at managing this. Now, partly the increase can be explained by the increase in people using GitHub. It grew by about 20% last year. But the amount of secrets that are being leaked is growing at a higher rate. And a lot of this can be explained by the fact that we're using more and more secrets now, using it in different ways. For example, cloud infrastructure now has really taken off and brought with it infrastructure as code. This is a new way of managing our infrastructure that codifies it. A lot of secrets are used in those code, which means that we're dealing with more secrets, which means that more secrets are leaked. So the problem is absolutely getting worse year over year. And it's a really concerning fact because, well, we should be getting better at managing things like this. Now, there's been some more concerning results around this, and that's kind of what happens after a leak is made. Now, I mentioned briefly that we actually validate the secrets that we find a lot of the time. So what we're able to do is check periodically if that secret is still valid. So we check multiple times in the first hour that it's leaked to see if it's still valid. And then we will check every several hours and every couple of days after that to see how long that secret, in fact, remains valid for. And what we discovered was quite concerning. After we alerted the developer that the secret has leaked, we would find that around about 92% of the secrets remained valid after 5 days. And pretty much after 5 days, you can assume that it's going to remain valid for a very long time after that, probably until the secret expires. That's really terrifying. It means that a lot of people aren't taking the appropriate action when a secret is leaked. If a secret leaks out publicly, there is really only one action that you can take: revoke the secret. That is because so many different systems are scanning and monitoring the GitHub code base, like GitGuardian are. So if a secret leaks, doesn't matter for how long, it will be absorbed and put into different data sets out there. So the secret will live on. Concerning to this too is only about 2.6% of the secrets were revoked within 1 hour of the notification email, which is typically what we'd kind of hope for out there, considering that this secret is public. So lots of concerning information around that, but actually it gets even a little bit worse. And that is because despite the fact that 92% of the secrets remained valid after 5 days, we also saw that people were actually taking some actions. Around about 72% of the repositories that contained elite secrets were actually removed shortly thereafter, or deleted or made private. So what does this tell us? Well, this tells us is that people are getting the notifications and they're taking action, but it's the wrong action, because just by deleting the repository doesn't solve the problem at all, because the secret is already out there. It's already in the ethos. So this just goes to show that there's really a lack of understanding of what to do when a secret leaks, and kind of the knee-jerk reaction is to just delete the repository or commit. So that's kind of concerning of what we've seen out there. Now, each year we can also look at some interesting stats as to, what countries leak the most secrets. Now, what you'll probably notice is that the countries near the top are the countries that have some of the biggest developer communities. So this isn't really indicative of if any certain country is better or worse at leaking secrets per capita. I think what this more interestingly shows is that this is a global problem that everyone faces, right? No one country has solved this at all. It's something that all developers from around the world, from India, United States, Brazil, China, everyone is leaking secrets. So it's something that we really, as a global community, need to really get better at. Now, some other interesting results that we have is we can look at what industries are leaking secrets. And this one is particularly interesting. The number one industry that will leak secret, no surprise to you, I'm sure, it's the IT industry, right? Tech, it's software engineers, it's our software houses, it's the big tech companies. And that makes sense. There's a lot of them. They should be contributing to a lot of code. But what's also interesting is all of the other industries that are touched by this. Manufacturing, healthcare, news, science and technology, retail. Everyone is exposed to this problem of leaked secrets. It's not just a tech issue. It affects every single industry in the world. And that's because every industry in the world is a little bit, in part, a tech company as well. Because it doesn't matter if you're building AI quantum computers or whatever the trends are, or you're manufacturing paint, you're going to have a lot of internal software designed to help you be able to do that. Manage your manufacturing processes, your sales cycles, manage your trade secrets. So all of that we need to be considerate of. So this isn't something that just affects software houses. This is something that affects every industry and every company around the world. And as we can see, there has been lots of leaked secrets from lots of different industries all over the world. Some other interesting things that we can kind of look to is, what files were leaking the most amount of secrets. Now, number one, should be no surprise, is a .env file or an environment variable file. This is by far the number one file that we kind of see secrets in. Now, this graph is kind of interesting because it shows the percentage or likelihood of a file containing a secret. So there's a 50% chance of .env file containing a secret, which is really quite alarming. But we also have to factor in here the fact that there are going to be a lot less .env files on GitHub than, for example, Python files .py. So the numbers are a little bit skewed here, but it's still really interesting. And this is kind of a frustrating slide because a lot of these could actually be prevented with something simple like having a .gitignore file, having some policies around your Git repositories that would actually prevent these files from ending up there in the first place. So it just shows, again, the gap of what we have to do to be able to kind of move forward in solving this problem. Now, a lot of you will probably be sitting there wondering why. Why do secrets actually leak? If you ask any developer, I'm sure they will gladly tell you that hard coding secrets is not a good practice and should be avoided. And, well, they would be 100% correct. So why on earth does this still happen? Well, we actually have to look to kind of how the technology works. I briefly mentioned at the start, talking about Git, how it retains a history. Well, we can kind of visualize that here. If you're familiar with Git, you'll probably be familiar with a diagram like this. Running along in the center is our main branch. This is the main version of our software. And you can kind of think of this as kind of like version 1, 2, 3, 4 of your application. But how we build software is we create something called branches where we work independently. And often what you see developers do is they'll create a branch, they'll work independently. And if they need to use a secret, perhaps they'll hard code that. Not with the intention of leaving it there permanently, but with the intention that they're just going to test it, right? They're just testing to see if it all works. And then later on, or even immediately, they remove that. The problem is with the code systems and version systems that we use today, that history is retained. That means that secret still exists. It's just now buried behind the kind of top level. And this was one of the reasons why it creates such a big challenge. And even if it goes to code review, the reviewer won't actually see the secret because, again, it's buried in the commit history. And this is where the problem is. If that then gets made public, if that code sprawls into different places it's not meant to, that secret buried in the history is going to come along with it. But there are a few other reasons too. For example, we could see lots of secrets in log or auto-generated files. There may be a fact that there's no .gitignore file, which is what we just talked about. So some of these sensitive files actually slip through and end up being in there. And in that case, we also see lots of things like secrets.txt, where developers store secrets insecurely on their own machines for ease of use, but accidentally commit these into the code repositories. Other areas we see secrets that end up in template files. For example, if you're using a framework called Django, then there's going to be keys that are embedded in there right from the beginning, and you need to go in and remove them yourself. But often people don't, so they end up committed in that history. And even if it's just for one commit, they will stay in there. And the last reason that we see is that we just see a lot of people sharing keys on Git. And this is just a really bad practice, even if it's private, because that source code sprawls into so many different places. So I want to move away from just kind of talking about GitHub and Git at the moment, because this year we expanded our search a little bit to include some other areas of where we can find secrets. And we were really surprised by the results of which we saw with secrets that were inside packages, or in this case in particular, PyPI packages. So if you're familiar with Python development, you'll be probably familiar with PyPI, or it's the equivalent of NPM or Ruby Gems or Maven or other kind of package repository managers from there. And what is interesting about this is now we're not looking just at the source code, we're kind of looking at the final product. So you would expect that there wouldn't be any secrets in the final product. But as our research shows, there's still a huge amount of leaked secrets inside these PyPI packages. In fact, last year we found 11,054 exactly secrets that were leaked in Python PyPI packages just last year. This is really alarming. Now, I know that this number isn't as big as the 13 million that I got to boast about from GitHub, but it is still really significant. It is still a huge amount of secrets that are out there in public places in a finalized version. And this is every single year. So this is really a concerning fact. And PyPI isn't alone in this. We're seeing similar results in other package managers like NPM or Ruby Gems. So we're seeing that these leaked secrets are kind of sprawling out in more ways than just in our traditional source code. We're also seeing the number of secrets per PyPI package actually increase. This is kind of scary and alarming. It means that we're not actually getting any better at managing our secrets, at distributing them securely than we were before. We can also kind of see that there's some very interesting types of secrets that are in there. For example, in this type of package, we're seeing that about 5% of them are for Google Cloud keys, or another 5% for AWS keys. So things like cloud infrastructure are really prominent at making their way into these packages. Those are very sensitive keys. We're also seeing lots of other areas or other keys like GitHub OAuth tokens. These are tokens that can grant access to your private source code. So in this case, the attacker could find secrets in your PyPI package and move into your private source code, ultimately discovering more secrets. It's a really alarming trend that we're seeing. And as I said, these are getting worse. So we know that secrets are kind of ending up inside lots of different places. So what then can we do about it? Well, the obvious solution is to manage our secrets more securely, but also to be able to detect them when they leak, detect them before an adversary is able to find them. One other area on this method, on this approach of detection we looked at in this report is, can AI help us find these secrets? Now, you've probably figured out that GitGuardian, we do secrets detection. We do it very well. And we were very curious, is AI going to be a new standard, or can we use AI to detect secrets more effectively? So what we decided to do in this report, which is a lot of fun, is to actually kind of benchmark AI against GitGuardian. So we took things like ChatGPT and we gave him a task to try and identify secrets within code to ultimately understand, hey, is this going to be an effective use case for AI now or into the future? And we did get some interesting results, but it wasn't the results that we were really kind of hoping for, let's say, in this regards. So the first thing to look at is the speed. So if you're looking at maybe using an AI system to try and detect secrets in your area, you're going to have to use a lot of computational power. So if we looked at tokens processing per minute, then at GitGuardian, we're able to process around about 3 million tokens a minute through Secret Scanner. Whereas ChatGPT 3.5 is able to process about 2 million tokens, and ChatGPT 4 is getting a lot slower at 300,000 tokens. Now, we're going to see this trend a lot between ChatGPT 3.5 and 4. In fact, the GPTs do get a lot slower as they develop. That's because they're processing more and more information. The AI model is getting bigger and bigger. So we know now then that this is going to take a significant amount of time to be able to detect secrets. But what does that translate to in cost? Well, it's going to cost an awful lot of money. What we did is we tried to benchmark how much time and cost would it take to scan 10 million documents. Now, the number 10 million comes from how many documents we scan every single day on github.com at GitGuardian. We scan around about 10 million documents every single day, 365 days a year. So what would that actually cost in terms of computational expenditure and time if we were to use an AI model? And the answer is quite a lot. As this graph shows, if we're using ChatGPT 3, it would take 289 days to be able to scan that at a cost of $4,000. So obviously, that's quite unfeasible, but it actually gets worse. ChatGPT 4 would take 1,157 days and cost $200,000. So we can obviously see that just from a computational method, using AI isn't an effective way to scan for secrets. And I relate this to kind of using a Ferrari as a tractor in a farm. It's not going to be any better. It's going to cost an awful lot, and it's probably going to take a lot more time. And this kind of makes sense, right? These AI models are massive. They're not designed for this. And whilst they are good at recognizing patterns and things, using them in this case is certainly just not very effective because of the scale that they are. But we understand that they're going to cost more. Were they able to effectively kind of find secrets? And unfortunately, the answer was, well, not really. So we gave ChatGPT and the GitGuardian Secrets Scanner 1,000 documents to scan that we took randomly from GitHub public places. And we tried to find out, how many secrets they could detect within them. So the results was that ChatGPT found 402, whereas GitGuardian found 8. And if we take a closer look into that, we took 1,000 documents. ChatGPT found 402, as I said, but 396 we discovered were false positives under investigation. So they weren't real secrets. 6 of them were, but there was 2 secrets that were actually missed. And GitGuardian, we were able to capture all 8 secrets. So what is this all kind of to say? Well, actually, it's just to say that AI is interesting, but it's not going to be a good use case for secrets detection in this way. And of course, this is 2024. We can't have any kind of webinar and not talk about AI. But are there effective use cases for using AI? Well, there absolutely are, and also in secrets detection. At GitGuardian, we're using AI to provide contextual input around secrets when they leak. This means giving the users more information about the type of secret, how to remediate it based on public information, and running that through an AI model to assist them. We're also using it to provide detailed analysis on how to actually store secrets within certain systems. So by analyzing the kind of systems that a developer is using, and then be able to provide information if they leak a secret of how they should then store that secret. So these use cases are interesting and will be coming out in the future, but they're much more, or they're much better use cases for using AI with secret detection than running the model to try and detect secrets themselves. So unfortunately, if you were planning on using AI to detect secrets, I'm telling you now that it's going to be a very expensive, costly, and long process to implement that. All right. So these are some of the interesting things that we have in the State of Secrets Sprawl report, and you can download the full report from GitGuardian.com and analyze that all you want. But right now, I want to talk about the GitGuardian product and actually like what we do and how we can help solve the issues of secrets detection. So at GitGuardian, we're a code security platform, but what we really specialize in and what's in our core is detecting secrets. And we do this in a number of different areas, but primarily out in public and then also in private. So we detect secrets in public places like GitHub. And we have a very unique ability to be able to do this. Because I said way back at the start that we scan every single commit that happens at GitHub, we actually have a very good understanding of what's happening on the GitHub ecosystem. But we also have a unique ability to be able to map employees with organizations that they work for. So if an employee leaks a secret on their personal account, which happens very often, we can actually alert the organization that they have a potential breach. But on the other side of things, we can also detect secrets in private, in your private code repositories, even in your Slack channels or in your Confluence areas. And we do this all in a very sleek and effective dashboard. But I want to talk about the value that this brings here, because we've talked a lot to this point or up to now about detecting secrets. But you may be surprised to hear me say that detecting secrets isn't actually the biggest challenge of kind of secret detection. Now, why would I say that? Well, it's actually the next step. Here's the truth. If you roll out secrets detection in a large organization, you're going to have a huge number of results. It's just the reality of the problem. But what do you actually do once you find the results? Remediation is really difficult, and that's because there's so many different stakeholders. For example, if a developer leaks a secret and a security person gets the alert, they then need to communicate with the developer to try and find out what does that secret actually do. They then need to work with the operations team or other security team members to get a new secret issued. They then need to fix the problem from where it was, redeploy the application with the new secret, and they need to revoke the old secret, all without creating any downtime. And not only that, the next day, you're probably going to have very similar incidents to go through all over again. So what we really thrive to provide value at GitGuardian is more than that. We're very good at detecting secrets, but that is a given, and we should be. But what we're really also good at is helping you remediate that. We bring together lots of different stakeholders in a seamless fashion. Developers and security people have access to our dashboard, but only see the views and the information that's interesting to them. Developers can help collaborate on the incidents and help speed up the process so they're not just a bottleneck. But also, really importantly, we have tools to help prevent secrets from being leaked, to stop the bleeding, as we would say. And that is the help on the developer's side, that they can implement tools that if we find a secret, we can catch it early so we don't need to go through the remediation steps. And then lastly, we also have great in-depth analytics along your results. So you can see what teams are struggling the most with secrets management. You can see how you're improving and how the tools are being used and are they effective. These are really critical in understanding our security posture. So what does the dashboard actually look like? Well, we can help you get visibility into your entire software development lifecycle with regards to secret. Now, obviously, this will include your source code, your private source code, and your public source code. But it will also include things like your Slack messages or your Jira tickets. These also often contain secrets and are a big risk to your organization as well. In our dashboard, we bring all of this information together to help you get a holistic view throughout your entire software development lifecycle of exactly where your secrets are. But once you have your secrets, it's not enough then. We help you prioritize that. We can automatically assign values of severity of your secrets so that you are able, at a snapshot, to understand what's most critical for you to tackle. What are the highest criticality of secrets that you can deal with first? Which ones are public? Which ones are valid? And you can also create custom rules around this. For example, you may have critical systems that you deemed much more important if they leak than others. You can set up these rules so that always the most important issues are delivered to you first to help you on your remediation workflow. Next, we help you understand the context around secrets, all at a glance. We don't just give you a secret and tell you to deal with it. We help you understand all the individualities, where that secret is, what team it was leaked in, who was the developer that leaked it, what is the code surrounding that, when was that secret leaked, is it public, is it valid, and all of these different areas. We can also then help you assign that to different team members so that everyone can collaborate. And that brings me the next step, which is bringing into the developers. Traditionally, if you find a secret and you need to communicate with a developer, there may be some really long, slow communication in understanding what this is. Developers now actually get access to secret leaks through the GitGuardian platform, but only the secrets that they leaked themselves. This is really critical because they can then actually understand and provide context immediately when a secret is leaked. We can shoot them out a survey, or they can log on to the dashboard the minute a secret is detected, which is basically exactly when it was leaked. They can then provide contextual analysis around that to the security team so that all the team members have all the relevant information immediately at their fingertips, and they can take appropriate action on what to do. We can also set up so that the developers themselves can actually remediate and take ownership of the entire process. And the system is really great at this because we can say that a developer can resolve an incident if they choose so and the secret has been revoked, and we can check that the secret is no longer valid. So this means that developers aren't a bottleneck in the security process. They're actually contributors to it. They can help resolve the incidents and get it out there fast. But all of this means nothing unless we're actually solving the problem, unless we're fixing the bleeding. And we can do this by detecting secrets at multiple different places in the software development lifecycle. Now, the most important place to detect secrets is in the repositories themselves, because this means that they've leaked. Whether it's public or private, if they make it to the version control system, we can consider that these secrets have leaked. But we can actually catch them before this moment. For example, we can install things that we call Git hooks on developers' machines that run after they make a contribution. And if there is a secret, can actually block that from reaching your external servers. And why is this helpful? Is that we can catch the secret before it actually leaks, meaning the developer doesn't need to rotate that secret. They can then go back and fix the issue on their own and redeploy the code. So this really helps that process and again, stops the bleeding from coming through. Now, the other part of this is we are able to do this in tools and in ways that relate to developers. It's no good giving a developer a security tool if it doesn't fix into their workflow. With our developer tool, GG Shield, it fits into their developer's workflow so that they can actually start taking control of this as well, with tools that they expect and that they intuitively know how to use because we build it into their existing workflows and systems. So this is really how GitGuardian can holistically help you deal with those problems of leaked secrets and secret sprawl. Well, I hope you found this webinar interesting. That's all that I have for you today. And I hope you enjoyed listening to the report of the State of Secrets Sprawl. Please, if you want to read the whole report, you can do so by going on to GitGuardian.com. And the other area is that if you would like to know what the risk for your organization of leaked secrets, and you would like a custom report of if any leaked secrets have made it out publicly, then you can do that now by contacting our partners who are hosting this webinar, and they will help facilitate you getting that report of your organization so that you can understand if you have any risk of leaked secrets right now. And of course, that is all free of charge. So thank you so much for listening. Again, my name is Mackenzie Jackson. I'm from GitGuardian, and I really hope that you enjoyed this webinar here today.